All right, so this is the function that we were giving. This is the graph that we were given, and we need to figure out, well, what might this graph, what's the equation for this graph? What might be an equation for this graph? So there's a couple things that you need to notice here. One is that I have a couple of vertical asymptotes. Right here. Little Mr. Ducky can't get past those points. Okay. So I have a vertical asymptote at -2 and at 2. That's telling me that in my denominator, I can't have x equal to 2 or -2. So I have just gotten my denominator for this function, which is going to be x plus 2, x minus 2. So by knowing what my vertical asymptotes are, I have the denominator. Now, if the graph had been drawn with, let's say there was a hole over here, which there's not, I would know there was another factor. I would know that if that's -8, there would have been another factor over here of x plus 8. Now, there's not a hole there. All there are these vertical asymptotes. But I just, you know, if you saw that there was a hole, that would give you another piece of your denominator. Now, another thing that I noticed is that there is a horizontal asymptote here. So the horizontal asymptote, the fact that it's horizontal, is telling me two things. First thing it's telling me is that it is either proper or improper. But since the horizontal asymptote isn't at 0, I know that this function is improper. I know I'm going to have a power of x in my numerator that is going to be the same as the power of x in my denominator, because that's what defines it as improper. Let me stop there. Make sure that any questions on what I'm saying here. Yes, please.
Can you repeat why it's improper?
Okay. So the horizontal asymptote is at 0 when it's a proper rational function, right? And the horizontal asymptote is at leading coefficient of numerator over leading coefficient of denominator if it's improper, right? Okay. If I go one more level up to really improper, it's no longer going to be horizontal. It's going to be oblique, right? Well, it's horizontal. Right? It's horizontal, and it's not at 0. So it's telling me that my rational function is going to be improper with the same power of x on the numerator as in the denominator. Does that make sense? Okay. So I know if my denominator is x plus 2, x minus 2, which is the same thing as x squared minus 4, my numerator is going to be some value of x squared. But the horizontal asymptote isn't at 1, which would be my leading coefficient of just plain old x squared over x squared minus 4. Right? My horizontal asymptote is at 3. So I know that it's 3x squared over x plus 2, x minus 2. Now the other thing that I know is that I have an x and y intercept right there at 0. I have an x-intercept that's really the one that I'm concerned about right there at 0. If I have an x-intercept there at 0, it means that my function, r of x, has to be equal to 0 where my numerator has to be equal to 0 where my numerator equals 0. I got to stop there and make sure everybody understands what I just said. I have an x-intercept. X-intercept tells me where my numerator is equal to 0. Somebody asked me a question. I'm getting like kind of halfway I understand this looks.
What does that mean?
Okay. What does that mean? That's a good question. where I have an x-intercept, that means y is equal to 0. We're okay with that?
Yeah.
Okay. I have an x-intercept right there, right? At 0, 0. So I have an x-intercept at 0. That means my numerator equals 0 at the x value of the x-intercept. So, in this case here, x, if my intercept is at 0, how do I describe this? When x is 0, is my numerator going to be 0? Is it? If I make x 0, is my numerator going to be 0? Right. So this is fine.
Oh, yeah, because 0 can't be the denominator.
That's right, 0 can't be in the denominator, but it can be in the numerator. That's going to determine our x-intercepts. But what if so let's say I had the same vertical asymptote here. Let's say I had a horizontal asymptote here, and my function looked like this. But in this part here, it touches there. Okay, my denominator is still x plus 2, x minus 2, so it's still x squared minus 4. I still have a horizontal asymptote that is not on the x-axis, so that I know that my numerator has to be some power of x squared, correct? Right, so that it's going to be improper. But my intercept isn't at 0. My intercept is at 1. What's that going to do? No, what's going to be the leading coefficient of my numerator here? It's going to be -2, right? Because I'm going to have -2. That's going to give me the value of my horizontal asymptote. You follow, right? Okay. But what's going to happen? But my intercept is at 1, right? So if my intercept is 1, I know y has to equal 0, where x is equal to 1. Right? Because that's the definition of my intercept. X is equal to 1. That has to make y equal to 0. What's my numerator going to look like? Were you going to answer? Yeah.
No, I was going to interpret that.
For the horizontal asymptote? Okay. What's my numerator going to look like?
-2x squared plus 1.
You're getting close. You're getting close.
-2x squared plus x.
No. Let's just write your thing right there. Negative. Let's go this. I'll show you. Let's just give you the answer. -2. If I said plus 1, then what value of x would make my numerator 0?
-1.
Right, but my intercept is a positive 1.
Oh, -1.
X minus 1 squared. Right. This is telling me, that explains why my intercept is here as opposed to some other spot. Right. This would make my numerator 0. Is there a question on that? Yes, please.
Can you solve by just setting y equal to 0 and then solving for, or like is there a way you could solve it so that way you could find out what x would equal?
Yes. Okay, so that's a good question. Okay. So I know that my numerator has to be equal to 0. Is everybody clear on that? That's really important. My x-intercept for my numerator is equal to 0. Okay. So I know that 0 has to equal something. And I know that it has to equal x minus something, let's call it, right? But I don't know what that is. Let's call it minus a. Okay. And I also know, are we okay with that? Okay. Well, I happen to know that x is 1, right? Because that's where my intercept is. Right? So if I say x is 1 equals 0, so 1 minus a equals 0. I subtract 1 from both sides, I get negative 1 equals negative a. I get a is equal to 1. Right? So x minus 1, which is just what we have. And that gives us our numerator. Yes? Okay with that? All right.